Good day, seniors. In this video lesson, we'll be having probability of intersection of events. Before we go to that, you must determine first whether the events are dependent or independent. It's very important. Two successive events, A and B, of the same experiment which do not affect or depend on each other are called independent events. The probability of two independent events, A and B, taking place in succession, so that's important. The two events are in succession. So PA intersection B here is equal to PA times PB. So simply multiply their respective probabilities. And if the result of this should be if the result of one event is affected by the result of another event, the events are said to be dependent events. So if two events A and B are dependent events and A occurs first, then PA intersection B is equal to P of A times the probability of B once A has occurred. So after A. So that's it. So very important. They're basically the same. You multiply the probabilities, but in the case of dependent events, the probability of B will be once A has happened or occurred. So to show that, I have prepared some problems. Let's go. A box contains 4 blue balls, 6 red balls, and 5 green balls. One ball is taken from the box and then replaced. So what do we mean by replaced? After taking that ball, the ball will be put back into the box. Another ball is taken from the box, so that's the second chosen. What is the probability that the first ball taken is red and the second is blue? So now we have these two events. The first event is, well, let's denote P of A as the first event. So the first ball. Then P of B, our second ball. So this is the second event, or the second ball, simply the second ball. So what's the probability that the first is red and the second is blue? So P of A, so we have to pick one ball. So if it's red, the probability that it will be red will be 6 over the total number of balls, which is 15. So we simplify this, of course, but this will be 2/5. Now, what is the probability of taking the second ball as blue? Remember that the red ball will be put back into the box again. Therefore, the total number is still 15. So the probability that it will be blue would be 4 over 15. So the probability of the two events happening in succession, A intersection B, is simply 2/5 for the first ball and then 4 over 15 for the second ball. So this will give us 8 over 75. That's it. So the next. So basically it's the same problem as before. A box contains 4 blue balls, 6 red, and 5 green. One ball is taken from the box and is not replaced. So that's the difference here. The difference here is that this time the ball is not replaced. Another ball is taken from the box. What's the probability the first ball is red and the second is blue? It's basically the same problem as before. Red versus red, second is blue. But in this case, the ball taken, the first ball taken, is not put back again. So basically, it's the same as the first one. So the probability of getting A, so P of A times P of B. But this time, remember, the second event will the second event, which is getting the blue one, will be depending on the event that will happen in the first, right? So this would be P of B once A has occurred. Once A has occurred. So now what's the probability of A? We're taking the probability that it's red, so it will be 6 over 15, the total. Now, if we have taken the red, the number of balls now will be 14, because one ball is already taken and it's not replaced. So this time, the probability that of getting a blue once a red ball has been picked would be 4 over 14. So you see the difference here. So this would be 4 over 15, but here it's 4 over 14. So simplifying this would be 3, 7, it would be 12 over 7 times 15 is 105. can be divided by 3 pa. Divide by 3, 4. Divide by 3, this will be 35. So that's it for this. Let's have another. A card is randomly drawn without replacement until the first king appears. What is the probability that 3 cards are drawn? Now, we all know that there are 52 cards here, right? 52 cards in a deck, and then 4 of which are king. So there are 4 kings there. So you know the king of hearts, diamonds, flowers, and spades, or clubs and spades. Now in the problem, what's the probability that 3 cards are drawn? Remember, it's drawing a card until the first king appears. So, said in the problem, the 3 cards are drawn. So, it only means that the first 2 cards drawn are not kings, right? So, if there are 4 kings, there are 48 other cards. So, the probability we're asked here, say, let's just name it probability A, simply a 3-step process. So, the first step being choosing a card that is not a king, right? So, what's the probability that choosing that card that's not a king? Okay, now it will be 48 over 52, of course. Now, the second card must also not be a king because it said in the problem the 3 cards are drawn, and the first king appeared in the third card. So the probability of getting a non-king again, a non-king card again, would be 47. So why 47? Because 1 already is chosen here over 51. Right? And then finally on the third card, the king was chosen, was picked. So it would be 4 over 50. So you see that what's happening here in the denominators. 52, 51, 50. Why? Because the cards picked are not replaced. That's important. Not replaced. So there, so just multiply this, and that's the answer. Okay. 48 over 52 times 47 over 51 times 4 over 50. So we have here the answer. 376 over 525. So there. And let's have one more. 2 balls are drawn from an urn that contains 2 red, 3 green, and 5 black balls. What is the probability that both balls are of the same color if the first ball is not replaced? You see that again? The first ball is not replaced. Now, however, we should be having cases here. Said in the problem that both balls are of the same color. It's not stated whether it's red, green, or black. So we should take it into account whether it's red, green, or black. So both are red. Case 1 would be both are red. Both are red. Both are red. There. So let's focus on this first. Probability that both are red. First ball pick would be 2 over the total. 2. That will be 10. Then second ball, obviously, if it's red again, it's only 1 over 9. So why 9 again? It's not replaced. So this would give you 1 over 45. So it's easy to simplify. Over 45. What about the probability that both are green? So first ball pick, both are green. First ball would be 3 over the total 10. Second, so successive steps. Second step, picking the second ball, which should also be green, so it becomes 2 over 9. So this is again easy to simplify. It will be 3, it will be 5. So it will be 1 over 15. Okay, and then lastly, both are black. So both are black. First ball, 5 over the total 10. Times, then second ball must be black again, so that it will be the same color, 4 over 9. So this is 1/2, right? And then this is 2. So the answer here is 2 over 9. So to answer this, what's the probability that both balls are of the same color? We add all these three cases up. So we have 1 over 45 plus 1 over 15 plus 2 over 9. So just use my calculator here. 1 over 45 plus 1 over 15 plus 2 over 9. So the answer is 14 over 45. 14 over 45. So now, just to relate this concept, this new concept, to ones that we already know before in combinations, let's go back to the definition. Remember, probability of intersection of events, you're taking successive steps. When you mean successive steps, there's a first step, of course, then a second, and then the third, and so on. So going back to the last problem that we did, here, we are taking two balls. First ball is not replaced. So, if you're taking two balls, wherein you will not replace the first ball that you pick, isn't it the same as picking two balls from the lot? You get my point. So if you take one ball and then you will not put it back again, then you take another. So there are two steps, right? So two successive steps. Is it not the same as taking two balls at a time? So you will see what I mean here. So if you will take both, if the probability both are black balls, right? In how many ways can you select two black balls? That is what? That is 5C2, right? Over, so you're taking probability. You're taking two balls from the total, 10C2. Okay, right? So this is it. This is for black balls. For here, both are green. Probability that you take both are green. That's 3C2 over 10C2. Now, if you have a calculator, try to get the value of this and this. And then both are red. It's the same. Is it not the same as 2C2 over 10C2? Right? Now you see. What is 2C2? Of course, it's 1 over 45. What is 3C2 over 10C2? It's 1 over 15. And what's 5C2 over 10C2? It's 2 over 9. I'm just relating this new concept to what you learn, what I think, I believe you know already. Right? So if you're taking successive steps, that's the point. In this case, you're taking two steps. Picking one ball, but you'll put it back again, then take another. Is it not the same as taking two at a time? So that's what I'm saying. So, good day, seniors.